Hello and welcome back, Chapter 12, Week 5. We're almost done, guys. Last lecture was rough. Last couple assignments were rough. From here on out, to me, it's a little bit more smooth sailing. So, especially this week, there seems to be a lot going on this week. But in realization, we're going to be talking about visualization today and on Thursday, and we're going to add in analysis of any kind of unstructured data or text. And that's really the two big topics that we're going to cover, even though it's like 4 chapters. Luckily, our chapters are nice and small. So put last lecture and the last group of assignments behind us. They're done, they're finished, and let's move on, okay? To me, it seems like the best way to just keep on going. So today we're going to talk just briefly about what visualization is and how it kind of compares to statistical analysis and what that correlation is. We're going to describe key characteristics in an effective visualization. We're going to introduce a function called ggplot2, and we're going to learn how to use it and kind of what is all in the background of being able to use that. We're going to look at a bunch of different visualization tools in different types of graphs and charts, and we've got a whole list of new functions that we're going to know going forward. So let's go ahead and get started. So visualization is basically giving a graphical representation of your statistical data. As long as you're graphing your statistical data, you're actually seeing that data. A lot of times it is easier to visualize and to use these types of charts and graphs to explain your data as opposed to just throwing a bunch of numbers out there. There are 6 key components in order to create a visualization. Okay, color is number 1. The color of each symbol can represent something. Okay, color is the most common, and a lot of times you can use it to indicate where on a sliding scale you are. Okay, now one thing to take into account with color is you do have colorblind people out there, so kind of be cognizant of that. It's actually a really good representation because our book is printing in black and white. At least my version of the ebook, it prints in black and white, so you can really understand how color could or could not help. Next, you can look at size. So you can use the size of your symbols, especially on a scatter plot such as this. You can see bigger circles mean something different than the smaller circles. Texture, so a shape of the symbol could mean something. You can have multiple things plotted on the same visualization, and the X's mean one thing, the triangles mean something else. You can use things whether it's a solid indicator or a filled in. Oh, solid or filled in, that's the same thing. A solid indicator, or if there's a pattern in it, that could mean something completely different as well. Proximity, so the location of your symbol on your X and Y axes. So you can see here we've got a grouping on that left hand side, kind of in the middle portion of it. So the location of it and the proximity of it to the other indicators, that's something that you can take note of. The annotation, whether we label our scatter plots, what are we labeling? Here we've got several different labels. We've got the color label and we've got the size label over there on the right. And interactivity, so selecting one or more symbols or perhaps zooming in. So you may want to zoom in on that part on that left hand side to really kind of blow up this section so you could really see it better, and then how that interacts with, say, some of these outliers over here. There are 10 important principles to keep in mind when you are creating your visualization of your data. Okay, number 1, simplicity. The whole point to me behind visualization is to make it for the masses. Okay, I like to use visualization and graphs and charts if I am speaking to people that aren't as involved and aren't as knowledgeable about what I'm speaking about as I am. Okay, so simplicity, great rule to remember. If you can hand a plot or a chart to somebody that knows nothing about what you're talking about and they are successful in interpreting your plot, you've basically won. Okay, so number 2 is encoding. So consider the type of encoding to use. For example, if you're going to make it bigger should be something, thicker, bolder, larger, okay, as compared to something smaller. So think about that plot that we just looked at. Those bigger circles represent something a larger scale, right? Patterns versus details. So focus on visualizing patterns or the details, okay? It's very hard to do both, okay? So you kind of pick one or the other. The ranges. So select meaningful ranges for your axes. You don't want to be cutting off data, but you also don't want your data so cramped that you can't understand what you're looking at. Okay, transformations, transforming the data could be useful. Do you need to do it as a log transformation? Sometimes a base 10 isn't going to work. Coming up here to the right, density. So are your points so on top of each other that it just looks like a line or a bar? Okay, you may need to play with the transparency. You may need to play with the fill. But what is the density in different parts of your visualization and what you're trying to relay? Connections. Do you need to connect your points with lines? Okay, is it sequential data? Things like that. Should it be a scatter or a line? Aggregates is the next. So combine data and visualization in meaningful ways. Okay, so you really want to understand and think about what your message is that you're relaying before you create your visualization. 9, comparison. Keep your axis ranges similar as possible, especially when you have multiple graphs. Okay, if you've got one graph and the spacing is a 1-to-1, and then all of a sudden you flip to a log, you might confuse your audience. And last but not least, color. We talked about that, selecting an appropriate color scheme. One thing again to keep in mind about color is printing in black and white, and as well as those colorblind people that may not understand color as fully. Now we're ready to start. So last time, I'm just ignoring last class. So the time before that, we created just simple histogram plots. And this was of the census information. We just used the histogram, the HIST function, and we sent it a column out of our data frame called states, right? We can make all kinds of other different types of bar plots with our visualization functions. So here, what we did is used a bar plot function. Okay, what we did is we sent it the column of the data frame that we wanted to plot, and then here we actually said go ahead and label these with the state names. Okay, this is showing the same data in a slightly different way. This is showing the data by state as opposed to in a histogram where it does those groupings. Okay, so you can really interpret your data to show what you need to show to your audience. Now, we can get much more advanced with visualizations. We have something called ggplot2, and it's going to work on a grammar of graphics, okay? And what you're going to do is you're going to build layers of information to be displayed. And we're going to go through, we're going to step through an example here in a second. So, for example, you're going to have one layer for data, you might have one layer for lines, you may have one layer for titles, okay? ggplot2 is the most commonly used visualization tool in R. It's the most customizable tool in R as well. In order to use ggplot2, you are going to need 3 things. You're going to need data, and it likes data frame, so data as a data frame. Then you're going to need your aesthetics. You're going to need to describe your color, your plot, things of that nature. And then last, you're going to need your geometry, and you're going to need to know what type of plot do you want. Histogram, scatter, bar chart, things of that nature. So once you have that bit of information, we can go ahead and start using ggplot2. Now, just like we had with those file libraries last lecture, we have to make sure that the library for ggplot2 is installed and activated, okay? The book gives a really cool little function that I have shown here that you can put in a script and save for later. it's basically going to do a few things. It's going to check to see if the library that you're looking for is already downloaded and activated. Okay, so if it is, it's just going to run the code. Okay, if not, it's not going to run the code. So it's not going to error out if that package is not installed. Okay, so this is a user-defined function. You can use it if you want. You don't have to. This does the same thing as that install and that library functions, or in RStudio, that bottom right hand corner with packages with the green check mark and the install button does the exact same thing. I usually just use the RStudio toolbox on that right hand side, but this is a neat little function to kind of keep in your back pocket of your toolbox. Now remember, we said ggplot2 creates and builds in layers. Okay, so here, let's take a look at this code and how it layered this code. So we defined a G, which is a variable. It's going to be a ggplot. Okay, here we're actually creating the plot. It's sending it the data frame, and you're telling it what you want the x-axis to be. So this is the column name that we want the axis, there we go, to be. Now, the next line, what it's doing is we're layering on top of that plot that we just created. Okay, so G equals G plus. Okay, so we're going to add some stuff onto it. This second line is indicating it is a geometric histogram. Okay, geom underscore histogram. Okay, with a color black, fill white. So we've got an outlined in black, it's filled in white. Okay, so that's what that second layer is doing. Now this third layer, we're adding upon it. So G assign G plus GG title. What that's going to do is give it your plot a title. So we're titling it States Population Histogram. So you can see how that appeared up here, States Population Histogram. And then what we do is we just put in the variable that we defined as the ggplot, and the output will look just like the plot up here. Now you can see how you can change things and how you do things step by step. I find that it's a little bit easier because I don't have to remember everything in one big large command. I can build it as I go. Okay, there's also nothing stopping you from displaying this G as you go along. You don't have to do all three. You can first define it and then see what it looks like. Make a change, see what it looks like. Make another change, see what it looks like. I like that sort of functionality in the ggplot. But now we can also create box plots. Okay, so we're doing the same technique here, but we specified down here that it's a GEOM underscore box plot. Okay, now let's take a quick look at what this code is doing, because we're not starting the plot until like halfway down in this code. So this first line is going to create a new column in the data frame. Okay, and we're calling it population change. So the whole point of this box plot is to see how many states have had a positive increase in population and how many states have had a decrease in population. Okay, so we're going to create a whole new column. We're going to call it population change. Now, what's going to go in there is just a, true or false, positive or negative. It's one or the other. We're just putting it kind of into buckets. Is it a positive or a negative? Okay. So the first one creates that column. The second line here populates that column with either a positive or a negative. Okay, so if DF states increase population, if else, if the population change is 0, make it positive, otherwise make it negative. Okay, so that's all those two are doing. What we're really concentrating on are these ones down here. So here we did the ggplot, we send it the data frame. Here we're going to have increased population against that other column. Okay, so here here's our factor on the vertical and our other column on the horizontal. So here the biggest difference is instead of using the histogram here, we used box plot, and it also flipped the coordinates. So basically instead of this being the X and Y, it rotated at 90 degrees. Okay, so you can see that here. And then last, again, it used that GG title and it added population group by positive or negative change, which appears at the top. When you go ahead and execute that G command, it's going to show you this visualization. So again, you can see how we're going to use very, very similar commands as long as we stay within that ggplot2 realm, and we're going to get a completely different outlook on our data. So let's look at some line and bar charts, because these to me are sort of the most common that we tend to make. For a line chart, you can see the second line, G plus geometric line. Okay, that's the biggest difference. We had histogram, then we had box, now we have line. Now here we also have something different. We've got something called a theme. Okay, all it's doing is it's kind of showing me what I want the x-axis to be. How here it's changing it, angle equals 90 degrees. It took these state names and it rotated them 90 degrees. So instead of being horizontal, they're now vertical. Okay, so that makes it easier to read your plot. Okay, and here it took the DF states. You want to go by state name, and you're going to do the July 11th population on the y-axis. Okay, so geometric line, and very, very similar, we've got geometric column. Okay, so this is your basic bar chart. It has the same exact thing here. Again, you can see your theme with rotating your x-axis titles 90 degrees so that you can read those state names. Otherwise, they would all be bunched on top of each other. Everything else is exactly the same, except for, again, that second line when you build that layer and you specify what type of visualization you want, which is geometric column in this one. Last but not least, let's look at a scatter plot. Scatter plots are going to give you a way to look at that data across 2 dimensions. This scatter plot is showing where each point represents a state, as you can see here. You can place the point on the 2-dimensional grid based on the population change, which is this x-axis, and the percentage change, which is that y-axis. In addition, we color the points based on that July 11th population. Okay, biggest difference, we've got geometric point here. You put the axes here and you specify coloring. You can add a text label and say that these are the state names. That's adding the label onto those dots. But this is really kind of difficult to read, right? You've got words on top of each other. This right here, I can kind of make out like Kansas, New York, Pennsylvania, but it's really difficult to read. So let's make this much more aesthetically pleasing. So let's define a set of key states, okay? What that's going to do is that's going to eliminate that big mass on that left-hand side. So these are going to be the states that have a percentage change of at least 1% and a population change of at least 100,000 people. So with this criteria, we're going to define a new column in the data frame states data frame key state, okay, to be true if that state is going to fit our criteria, okay? In the scatter chart, what we're going to do is we're going to show the key states by defining the shape of the symbol within the scatter plot to be dependent on the key state column. Okay, so when we come down here, okay, here. Nope. Okay, so in the scatter chart, we show the key states by defining a shape of the symbol within the scatter plot dependent on the key state column right here where it says shape. Okay, we also show the text of the state name only for the key states. Okay, so only for the key states, we're going to put the state name. Okay, we can clean up the format of the color key, defining 3 different variables to be shown in the key, as well as, there, right there, as well as formatting the numbers to include commas so the numbers are easier to read. So finally, we'll change the color scale range from white to black. Okay, there's a lot going up on here, but let's see what that does to our plot. Check it out. This plot is so much more readable and visually pleasing, and all we did is change the certain items. Don't be afraid to create new columns for data if you want to do something like that, okay? It's very easy with these data frames. This is, you can read exactly the ones that I want you to read. You've got key states, true and false. You've got a gradient on the circles, so you can see all over here your plot points. You can actually see them. I may not know exactly what state they are, but my guess would be, looking at this, I don't care what those states are. The states that I care about are the 3 that I have indicated. Okay, so make sure that you are relaying the information that you would like to relay when you're doing your visualization. Okay, next lecture, we're going to continue more on with visualizations, but we're going to learn how to be able to put those visualizations onto a map. Okay, it's actually kind of cool. So there is one assignment and one lab for today, assignment 6 and lab 6. Fairly easy, straightforward, no more file junk. Assignment 6, we're going to visualize that air quality data that we've worked with in the past and pulled before. Please make sure that you have your ggplot2 installed and activated, and that one I believe also uses a reshape 2. Okay, make sure both of those libraries are installed and activated in your RStudio, otherwise your plots are not going to work. Okay. Lab 6 is going to work with those cars again, okay, and we're going to do some visualizations with that. So really, we're just taking the data frames that we've already preloaded, and we are going to put them in some different kind of plots and visualizations and kind of play with them a little bit. As always, I'm available through email, and if there are any questions, just let me know. Happy coding!